There we go. Start. No, there we go. And this time, for the people who are in materials class, you can see this is now actually the correct class down here, not some other class. All right, orthographic projections. Why do we do? What is an orthographic projection? Well, if you remember back to some of the drawings that we looked at, for instance, at that like that metal discs drawing, right? We kind of saw different views of it, and so orthographic projections are one way of creating these two-dimensional views from a three-dimensional object, right? So basically, what it is a set of two-dimensional views of a three-dimensional object. So here, the example that I'm showing is my coffee mug, right? So you can see it from the front, maybe from the side and from the top, something like that, right? So this would give us enough information. If it weren't full of coffee, it would give us enough information to exactly describe the entire object. We'll probably need to have dimensions on it here, and maybe what kind of material it is, and all those kind of things. But the overall shape of the object is something that once we have these three views, we could easily describe, right? If we needed, if there was more detail, if there was, for instance, writing on it all the way around or something, right, then we might need to have additional views to see it. But the overall idea is that these orthographic projections are just a set of two-dimensional views to describe a three-dimensional object. And of course, every time I take a picture, right, that's creates a two-dimensional view of what we see. And orthographic kind of points to the idea that these views that we're going to see are on planes that are perpendicular to each other. Right? We can say here, like the view that we're looking at, would be like perpendicular to the table here, and then there it's parallel to the table, right? So all three are perpendicular to each other. Now, overall, if we wanted to take it all the way to the end, right, we could basically get six different views, right? If this was my cup again, here is my three-dimensional object. I can look at it from the front, would kind of give me this view. I could look from the very bottom of it, right? So I just see kind of the ring at the bottom and then how it opens up. I can look from the right side, I can look from the back, the left side, and from the top, right? So especially if I would take all of those six pictures, then I could definitely describe the cup in total, right? There wouldn't be anything left of the cup that is not described by those six pictures. Unless of course there's something happening inside of the cup, that is hidden by from all three views, right? So if this had a lid on it, then I wouldn't be able to see what's happening inside, right? Then I would assume from my pictures that this is a solid object, while it actually is, is hollow inside. But these are the six that we get, right? Front, back, top, bottom, right side, and left side. So this is where we start with the concept of a glass box method, right? So if we want to go ahead and find these six views in a kind of in an organized way, then we use what's called the glass box method, right? Where we kind of take our object. So that's why I had you made these little paper things, right? So if this is kind of as we have it on our screen, from my view, from your view, would be something like this, right? And now we take our object and we stick it into a glass box, right? This picture here is kind of this wire frame that goes around. That would be our glass box. And each of these sides of this glass box you can think of as, if you go back to the olden days of photographic plates, right? So this would be kind of a photographic plate, or you can think about it as a screen, right? So we have six screens that are now all around our box, and now all we're going to do is we're going to go and get ourselves right in front of one of those screens and look straight at our object, right? So we'll start with what we said before was the front view, right? So if we look through this first rectangle here, right? If we look into there, then this is what we'd see, right? So this is if we're taking our object, and where's my camera, right? If we're looking exactly like that, right? That's what we would see. Oops, not quite straight, right? Or if you take it and look straight at it, you probably have to close one of your eyes, otherwise you get too much dual vision there, right? But we see what we see here, right? We see the back right here, right? This is kind of the back here. And then we see this edge right here would be the edge in the back and the edge in the front. And then we see that we have something happening here, right? We kind of see this line and this line would be the two lines that we see. Now, this would be if we're looking from the front of it. If we're now turning ourselves around, right, and look from the right side view, right? So if we maybe go back to our box, right? So if we're looking through this window right here, so this screen, then we would see this, right? So now we're looking this way at our object. All we see is basically an L, right? And then the line that we see here, this horizontal line, right? That's this edge right here, that little edge that shows up. And then we can go slowly around our entire system, right? So we can look from the back. That's all we see, right? There's nothing else to see. There's just the outline and nothing else. And we can't, of course, we can't see anything about the depth here, right? Because we're looking straight at it, right? We're completely perpendicular to that, or like our viewing pane, our window is parallel to this to the front face of this object. Of course, this is easy to do with these kind of rectangular shapes. If you go back to my cup, right, then that becomes a little less clear where the exact perpendicular is. Now, this would be if we turn around and look from the left side, right? So again, let's go quickly back to our box here, right? Those would be looking from this back side, right? From this one right here. That'd be that, right? So all we see is this L shape thing, right? So now, because we're now not seeing, there's no cut here, there's no change, right? That means there's no line here. It's all nice and straight, right? It's perfect L. And then the ones that are left are the top, right? So this is if we're looking down on our object like this. So then now we can't see that this is slanted, right? We just see that as a straight line. That would be this right here. And then we see the rest, right? The bottom here with a little bit of a cutout. And then if we look from the bottom, then there's nothing else to see, right? It's just that cutout and otherwise a perfect rectangle. Right? So those would be the 6 different views that we can get of our little object, right? So if we wanted to take this object and perfectly describe it through perpendicular through two-dimensional views, right? Then we can take these 6 and that will describe it perfectly. And actually we'll see a little later that we don't need to even take all the 6. We can get away with way fewer than that. We can actually usually get away with 3 or less. So let's go back to our glass box. All right, so this is again our object that's sitting in our glass box. And now what we'll do is we're gonna unfold this box. Right, we're gonna take this front face right here. This is where we're gonna start, and we're kind of gonna take this box and just kind of flip all the panes as if they were kind of connected on some kind of a rubber piece or something like that, right? So and then if we do that, then we get something that looks like this, right? So we have the front view right here, then we have the right view, and then the back view, right? And that would be the left view, the top view, and the bottom view, right? I hope you can kind of see how this would kind of fold back together to that box, right? Just like we did the folding for this one, right? So you could do the same one if we cut allowed, if we cut around all this outside and then fold it along each of these straight lines, right? Then we'd go back to a box, and that box would then have the front, the 2 sides, the back, and top and bottom. Now, one thing that you can see here is that, of course, if we're unfolding these, then the overall alignment stays the same, right? So the height, if I look at the front of my object and I turn it left or right, then the height that I see here, right, this height, that height doesn't change. It doesn't matter what direction I look at it from. The overall height is always going to be the same, right? So that's what we can see here. So in my left-hand side, my left-hand side, my right-hand side, my back, and my front, this tip is always the same height, right? So the difference between the bottom and the top is always the same. And of course, if I look at other things, that would be also true, right? So if I look at this distance here from the little corner down to the bottom, then that distance is always going to be the same distance, right? So if I see the distance, I see that distance here, I see that distance here, and here. Of course, here in this one, I don't see it because on my backhand side, right, there's nothing here. There's nothing here to see. So that would be the alignment in one direction. Ah, there should have been an alignment in the other direction as well. I'm not sure how that got lost, but of course we can do the same. We can do the same thing, right? So we can have, if we draw dashed lines, and I don't have my, 1 second. Let me see if I can get my pad here connected real quick. Is my cable and my pen. That's what happens when you have to teach in all kinds of different places at the same time. Let's see how quickly this picks up. It did. Right, so we could do the same thing that we did left to right. We can do top to bottom, right? So if I do a dashed line in this direction, right, and a dashed line in this direction, then they all line up. These are all perfectly aligned. The same if I go in these directions, right? So if I go down here and down there, all of those would be lining up, right? So that's what that means for us, is that all of the shapes that we see on our system here, all of these are lined up, and that will help us when we get around to drawing them by hand. You will see that how that helps us. Now the question is, we have all these 6 views. Do we really have to see all these 6 views, right? And so basically what we're going to do, if we're going to draw these by, especially if we're going to draw these by hand, right, that means that it's going to take us a while to do it, right? There's some effort involved with drawing these. Even if we do it computer generated, still there's an effort that we want to put. And of course we don't want to put information there that's kind of doubled, right? So what we want to do is we want to go through and we only want to choose views that give us additional information, right? So here, we can probably say that the left side view here doesn't really add a whole lot to our information, right? Because from the other ones, it still has the same overall shape like my right hand view. It's just from the front view, I can see that kind of this change in the angle here, right? That it doesn't happen on this one, right? So I don't really need that one. Same I can say for the back one, right? There's really not much information that the back adds that I can't see from the front, because it has the same shape and everything. I can see that all these these surfaces here are all flat, right? So I don't have to worry about them changing. So I know everything has the same height. And the same with the back, yeah, the top and the bottom, right? So on the top, I can see I kind of know where this ledge comes in, and at the bottom, I can see, well, there's nothing else happening, right? So in this case, we could probably get away with these 3, and we'll talk about those in a minute a little bit more. But maybe let's have a quick look at some other examples, right? Other than our little shape, right? So now, if we think about this this cuboid here, right, up in blue, right? And if we think about that, and if we look at it in as these 6 views, right? Again, if we put this in that glass box, right, then this would be, we're looking from here, so this would be our front right here, right, and this will be the front in here, right? And then I can go around and look at all these different ones, right? So I see this side right here. Maybe we'll just say right would be here, and this would be our top. Our top would be here. Now we can't see where the bottom is, right? The bottom would be underneath. Can't even see it in this case. This would be the back, which we also can't see. And the left, we wouldn't be able to see either, right? That would be on this side over here. So these are all the views that we have. Now, if we wanted to you know, manufacture this block here, then how many of these views do you think we actually would need to perfectly make this block? You know, if there wasn't anything else, if it was just all the same color and the same finish, and how many? Sorry,
Three.
three views.
For
Yeah,
the height, the length, and the width.
we would need those three things. That's correct. But now the question is, do we need three views to give us that? Right.
No,
So
maybe two.
we need
Only top and front.
we can get away with that, right? We can say this one here, right? If that we say that's our height, right? If this would be our width, then that's all the information that we can get out of this one, right? But now from this one, we can get the depth, right? And of course, the width we'd see here as well, and so we can go from there, right? So these are the only ones that we'd actually need. So again, we were correct, right? The front and the top would be the only ones that we would need. Well, either or, we need two, right? So we could either do front and top. We could also do front and right? Because this is the same depth, right? This line and this line, are of course, the same. Right? Those represent this line right here, right? So we get away with that. We could also do top and right would also be enough, right? Because you had the width, the depth, and the height would be we'd get them from these from two of the projections, right? So if we have a block like this, you're right, two would be enough. How about for if we have a perfect sphere? How many views would we need
One.
here? One, right? Because for a perfect sphere, all we need is the radius, right? And we can get that radius from whatever view we look at, right? Doesn't matter what direction we look at this at this sphere, it's always going to be the same, right? So these would be special cases where we can get away with having uh, just one or two views, which is a little unusual, right? That's not the most common thing. So the most common thing is that we get three views, which we call the three standard views. We get the front, we get the right side, and we get the top. And in this case, in this class, whenever we do orthographic projections, we're going to do those three, right? And so you will have to then, basically, once you have your object, you will have to decide where the front is, right? And then based on where the front is, you'll know, the top and the right side then are very clear. And as we'll learn later on, we will see that some of the features that, so in this case, I made one where we don't need it, but if there were something happening on this backside here, right, that is relatively simple, then we can get away with what's called hidden lines, right? There will be lines that we kind of assume that we can look through this entire it as if it were transparent. But we'll get there. Nonetheless, these would be our three standard views, and usually we don't draw them with a glass box. Right? We'll leave the glass box away. We just draw those three views. Um, but as I was talking about before, these views always have this horizontal and vertical alignment, right? So again, this point here and this point there, right? They both describe this edge on top here, right? So on the front and the right side view, they have to be at the same location, and the same for all the other ones that we can see, right? All these other corners here, if they're on the front side, they have to be on the same location on the left hand view. Yeah, the right hand view. I'm sorry. So that's why all these dashed lines. And in the vertical, we do the same thing. Right? But this is where my vertical lines are. I'm not sure. Got two figures combined there somehow. Right? But again, so like the locations that we see here, right? These kind of the location of these two side pieces, right, are if I kind of do my turn for my glass box, right? Doesn't matter if I'm looking from this direction or from that direction, the location has to be the same. That's why we have these straight dashed lines. So when we have our three uh, standard projections, then they always have to kind of line up this way. Now, that is great to see, but that still means that I can move my my top view and my right view in and out, right? I can do the left uh, back and forth, the left and to the right, and it could still line up, and I could do this top one up and down, and those still line up, right? So now the third thing that we have to do is we have to actually line up uh, the top with the left side one, right? So now if you kind of think about that, if we open up our box differently, right? So if we maybe we just this is 19. Let me swing back to our glass box here, right? So at the moment, what we did is we took this as our front, and then we took this one up here and flipped it up, and the side one here we flipped to the side, right? But now, of course, if we took the top one as our starting point, right, and just flip the side one upwards and the front one upward, right, then this is then what we'd see. We'd see this picture right here, right? So basically, we're looking at it this way instead of this way, just flipping that, right? And of course, in that case, that means that anything that was lined up here, oops, other side, that's lined up in here, right, has to line up between the top view and our right view, right? So these all line up. And of course, if we go top to bottom, those have to line up as well. So now we don't have this picture in here, right? We only have the three views, not a double of the one view. So what we can do, because these are all right angles, right? We can draw a 45-degree angle line right through here, right? Through kind of that open space where like a fourth kind of box would go into, and 45 degree because these are all orthogonal to each other, so half of that is 45. And then anywhere where we have these our straight lines hit this 45-degree angle line, we drop a line that goes straight down, right? So we'd have these three lines go down, and you can see they all line up, right? So now this means we see that, for instance, the thickness here of our little object, right? That thickness is given here, and it's also given here. That's why it has to line up, right? The overall uh, guess width, I guess you can call it, right? So this distance right here, we see that here. Oop, where's my pointer? You guys can see my pointer, my mouse pointer, right?
Yes.
Yes. Okay, good. So this width here is the same as down here, right? So we see no, this one right here. I'm sorry, that one, right? That one right here is the same here, right? So I have my line that goes here, goes down, and my line that goes there and goes down. Right? This is how. So if we're doing our drawing, right? If we say, well, let's make a drawing of this little object here, then that's how we would do it, right? We would kind of look at the front, draw the front first, and then maybe draw the top, and then we can draw the other one using the 45-degree angle. And now, hidden lines, right? So I said what we do is we kind of act as if this thing is transparent, right? So now, because if we're looking from either from this side, either of the two side views, right? This view or this view, right? Then we have no idea that there's a hole here. Right? We don't, there's nothing that indicates that. And so in order for us to indicate that, again, we kind of pretend that this shape is semi-transparent, right? And so then we add this little dashed line here. And these dashed lines are what we call hidden lines, right? So in this case, if we were looking in this direction, right, then we see this edge here would show up as a hidden line. The same if we're looking from the back here, right? Then we can say my pen over here, right? Then we can say, well, this edge right here, right? This is where where it goes from flat to going up. Well, we can't see that here, so what we'd have to add. Now this doesn't work. Let me see. Get my pen to work. Probably should get a marker for this, right? So we get a hidden line that goes across like that. I'm not even sure that shows up on the camera, right? So if we do it on the back, then we'd have to have a hidden line. And we'll practice all of this as we're going along. Actually, we're going to practice that right now. All right, so what we'll do now, I'm going to switch the camera. I'm going to hope that that doesn't interfere with the microphone. I'm going to switch over the camera and we're going to do this drawing, or I'm going to do this drawing, and you can watch. Let me stop sharing and switch the video. Let's see. That seems to have worked. All right, and I can go. Actually, need to keep this shared so I can see the overall piece. Make this a little bigger. One second here. Oh, I guess it doesn't want me to go back to the regular one. One second. I need to figure this out. Maybe, yeah, we'll leave it as is, I guess. I can probably see enough. All right, so now we see my piece. You can see my piece of paper, right? So we'll take my pencil and my ruler, and we're gonna have all these units are given to us here, right? The dimensions of our little block. And let me just jot down those numbers real quick. So I didn't realize I couldn't have them up on the screen at the same time. 0.5111, 125, and 275. Okay, I think that should be sufficient. So this way I can see what I'm drawing. How do I? So usually it allows me to have these side by side when I do a screen share. Aha, control for multiple windows, maybe that. Hmm. No wonder what's going on. I'm sorry about this. Usually my hmm. Well, I hope I can figure out that better for next time, right? So let's see. So we want to do our drawing, right? So what we'll do is we'll start with our front view, right? Our front view would be, again, oh, now you can't see that camera anymore, right? So the front view would be something like this, right? Where I'm looking from my direction, oops, more or less like that, right? So we can start, for instance, with this corner down here, right? So if we, or even better, let's start with that corner from here so we can go from left to right, right? So if we start with that corner, we'll just choose anywhere on our piece of paper to start. Right? We want to give us a little space, so let's say we start right down here. You guys see what I'm drawing, or
Yeah, a bit.
maybe zoom in a little bit, huh? Let's have this, maybe make sure that it focuses correctly. Maybe that's better.
Yes.
Okay, so this is where we start, right? That would be the corner down here. Now we know that the first part here is 1 unit wide, right? So we'll have to go 1 unit. In our case, we can probably get away with, let's see if we can get away with 1 unit being 4 boxes. All right, so let's do, we see 1, 2, 3, 4. So that would be our first line. Right? We want to make nice strong lines. Now, if we're looking at our piece from that direction, let me go find the right spot. right? Then we won't be able to see that there's nothing here. We just kind of see this back line straight away, right? So we need to do another one, right? Basically, if we're looking from this direction, we see this back line right here, right? So that would be another 4 steps. And then another 4 to get all the way to the next corner. Right, so this would now be this entire line going from left to right. Again, we can't see that there's a hole because we're looking straight at it, and all we're seeing is that. All right, so then let's go up. Right, it says this height is 0.5, so we'll go, that'd be 2 units in our case. Is this where I'm drawing it? Let me move up a little bit there. So we'll see it at that edge and at this edge. And then we also see it 4 in, right? 2, 4, we see these kind of cut out edges. 2, 4. And then we go across. Right, so this is a little bit slimmer than our actual model is, right? Just from how the system worked. Right, so now we have basically the bottom of the front view. All right. Now we see that if we want to do the back side, right, the kind of the upward facing part, right, then we know that's 1.25 units from the bottom up, right? So, but in our drawing, we're already 0.5 up, right? So that means we're just we have 3/4 left, right? Because 1.25 minus 0.5 is 0.75. So 3/4 in our case is 3 boxes, right? Because we said one is 4 boxes. So we have that height right there. And then on the other hand, it says 2.75 starting at this edge right here, right? So that would be 2.7 by it is 8. 8 boxes plus 3 boxes would be 11 boxes. That's pretty high. Might be a little too big. We'll see. 1, 2, 4, 6, 8, 10, and 11. And then we can just connect those two. All right, remember we want to make nice strong lines, right? So that they kind of are distinct from the background. So everybody saw how we got this first shape?
Yeah.
Yeah? All right. So then, are there questions? I guess just...
Dr. Bandila, I'm a
Yeah.
little bit confused. I thought the 3 boxes are the ones that you see in the front view where you have like the hole in the center. Is that where you're drawing?
This is my front view. This is the hole. This is kind of where the hole is, right? If you see my
Okay,
pencil
yeah.
right now, right? This would
Yeah.
be where's my object? You have to get it into the camera, right? So this would be that open space right here, because we see when you're looking straight at it, right? We see this back part.
Yeah.
We can still see that. So if we were looking straight at it, we wouldn't notice if it's at the same height as these other two sides. Is it farther in or farther out? We don't know. That's what we use the top view for.
Okay, okay.
All right. Okay, so now that we have the front view, let's do the top. Right. So if we're looking at the top, let's give us a little bit of space, but not too much. Maybe we'll start right here. Right. So usually I wouldn't do dots there, right? But just for us now to start. Right. So this would be now basically we start with the same corner, just not at the bottom, but this time we start at the top. Right. So we can say, well, what do we want? Well, we can go in. You can see this first line here, for instance, right? The one that's going in. So that would be 1.5 plus 1.5 is 3, plus 0.5 is 3.5. That would be, boy, that's 12, 14. Oops, let's hope we can get that on our page here. 2, 4, 6, 8, 10, 12, 14. So that would be all the way up here. So this is now the line that I just drew is basically this line right here. Oh, but that's not correct. right? What I just drew is the length that goes from here all the way to the back. So I shouldn't have put the half on there, but that's fine because we need that anyway. So all we have to do is kind of remember that we want to stop at that point. All right, so now if we go back down to this corner and say like, well, where does it go from there? Well, it goes one over, just like it does, of course, in the front view. Right, so now we see like where I did that red dashed lines, right? These kind of edges line up between our two different views, right? The top view and the front view. These line up. Same as these two lines line up. Now we have to do, we're at this corner, so we have to go in, and in would be 1.5, right? So in our case, that's 6 boxes in. So that'd be 2, 4, 6. Right, so I like to count them out and then draw backwards, just because then it's easier to know exactly where to stop. And then we can go over. So either we can count how far we have to go to 4, or the other way that we could have done it, right? We could have gone down here and kind of done a construction line to tell us, well, this corner has to be here because it has to have the same width down here. Oops, you can't see that. The same width down here as it has here. But often for these simple ones, to me, it's easier just to count them out. And then, of course, we have to go back to the same that we had before. And then to this corner, it's another 4. We've counted that a couple times now. And then now we hope, of course, that we better have the same location here, and we do. Right, this lines up, so that's good. Now we can take our line here that has to go all the way to the back, just like the other one. And now, as you can see, I drew it a little too long, so let's make sure we erase that. So with these drawings, you want to be nice and precise, right? We want to have nice, thick lines that we can see, and whenever we need to erase something, we should make sure that it's completely erased. Now, for this back line here, right? So if we look from the top, then we can't see that there's any angle to it, right? All we see is that there's a line going across. So all we have to do is draw a line across. One here, and then the other one right there. Right, that's what we counted before. So this would be kind of what we see here is the top here. Is this edge. Oops, where's my camera? There's my camera. Right, this is that's what we drew here. All right, so now we have the top and the front. And now what we have left is our side view, right? Our right side view, which would come, of course, right down here. That's where we want to put it. So now what we want to do is we want to kind of make our 45-degree angle, and it really doesn't matter exactly where we put this 45-degree angle. It will always, it would kind of, where we put this angle in this kind of parallel direction here kind of tells us how far the right-hand side is going to be moved in there. So maybe we'll put it somewhere here. If we do it there, that's going to be too close. Maybe somewhere here. Let's do it there. Right, so we'll just draw a, oops, where is our 45-degree angle line? There it is. All right, so we'll do it, there it is. Do it nice and soft, right? So this is not a real line, so we'll do it soft so we can easily get rid of it later. Now, if we want to start drawing, right, then we can start with any of these edges here. Again, do a very, on the thing, right? So we can do a nice thin line to extend these points, and so we know they have to go down in this direction. So again, we do a thin line, and now we know that this part right here, right, would be the edge on the front. So it has to have the same height as we get, as we get down there, right? So we know we have a point here, and of course it has to have the same height. So we can do a straight line there. And now if we want to know how far back this goes, then I hope we didn't draw ourselves into a corner. Oh, that was lucky. If you can see, our construction line goes all the way to the edge, so we just perfectly fit it in here. That was I have to admit that was by luck, not by design. Right, so this would now be the side view of this edge right here. So that means we started here, we've drawn all the way to there, so now we can go up 1, 2, 5. So either we can kind of do the construction of it, or we can just say, well, we know we need to go straight up. 1, 2, 5 is 6. 1, 2, 3, 4, 5, 6. I miss. Oh, 1, 2, 5. That's not 6. That's 5. See, I was going to say like I miscounted somewhere, but this is 5. 2, 4, and 5 right there. That would be this corner. But of course, remember that if we're looking in this direction, right there, right, then we see this edge, but it doesn't stop there for us. All we see is that it kind of continues on, right? So now we can draw it all the way to the top. So we can kind of see where is this top. This top has to be somewhere there. So we can draw it all the way up to here. Now, we'd be up on this corner basically. So now if we want to do this side view, where do we go? There. If we want the side view, then now we have to go across. Right? So that's what we can do. We know those are 2 across. So we can just do 2. And then of course we know that this has to go, the inside edge here has to come all the way in. So we can draw that as well. And that has to line up with this one. So that'd be there. And then that connects up here. And let's not forget that if we're looking from that direction, then we see this edge. Right? So we have to draw this edge here in as well. So we just draw that as a straight line across. And the reason why we have to put these in is that now if we were doing this, if we wanted to create this 3-dimensional drawing out of our 2-dimensional, out of our orthographic drawings, right, which we'll do next week, then if we see this line here, then we know, well, there's something going on, right? We have to look at the other 2 views to make sure what's going on. And in our case, we look here and we say like, well, we can see that there's a change in height here, right? So we can, that's what we see. Now there's 2 more things left that we have to do. Number 1 is we're going to have to erase our little construction lines, which is going to be easy because we made them real nice and thin. The other thing is that remember that we always kind of pretend that these are semi-transparent, right? So what we have to do is we have to add kind of where this opening is in, right? So we have to add a dashed line here as a hidden line. And so we know this dashed line, right, has to be somewhere here, of course, on our side view. And we know it is going to be this far in, right? The 1.5. So in our case, that was 6 blocks in. So 1, 2, 3, 4, 5, 6. So here we want to do a dashed line. And we'll talk about rules for these dashed lines, but just to begin with, we always want to have our dashed lines start and end at an actual line, right? So we have this little dashed line. Especially if these are smaller, right? Then it's sometimes difficult to make these lines nice and evenly spaced and still be dashed. All right, but let's not forget to erase our couple construction lines here.
Dr. Bandela, why did you draw the diagonal lines in the from the beginning, like the constructions lines? Why are they necessary? Yeah.
They are not entirely necessary. It's they're kind of helpful at the beginning, right? So they help you to kind of place the right side view in accordance with the other one. But it doesn't. There's convention that says that we want to have these 3 views together, right? That the front view is kind of in the bottom left, the top is above, and the right one is to the right. That convention is always there. But the kind of relationship between the top one and the right one is not necessary, right? So I could take this and move it a little closer or to move it a little farther away. But if I want to have it that the top one is at the same distance as the right side view, then I have to kind of do this line. But we could have just done the front one and said like, well, we'll start at any point here and start drawing, and then we could have still done it, and it still would have been fine. It's just at the beginning, some people think it's easier to use that diagonal.
Okay, okay. Thank you.
But if we do use it, then we do have to get rid of it at the end. All right, so with this one here, let's erase our lines. When we're done, we want to have nothing left but our actual lines. And I think now we have everything left except our lines. Let me push that up into here a little bit. Are there any questions about how we went about drawing this?
No.
No? Good, because you'll have to do some of those in not too long from now. But before you do that, let's do one or two more things. Let me get into here and
Dr. Bandila, I noticed that you had like two templates in Blackboard, like the course orthographic paper and the other one.
yeah, this one.
Does it matter which
This
one
is
we
the fine
use?
one. So if you want to do it exactly like I did here, you should do the fine one, just because it's the boxes are a little smaller.
Okay, okay.
But either or works. Okay, I'm not sure why that happened. So what would I want? I just really wanted to go back here and change the camera. Well, we're still working out the early semester kinks, I guess. Let's go back to this one. Turn this one off so we can save the battery, and now see if I can share PowerPoint again. Yes, start from current slide. There we go. All right, so this is what we did this drawing, and you'll see, from our drawing that the drawing that I did here in PowerPoint doesn't really fit to the exact dimensions that I put on here. I put these dimensions here just because they make it easy to draw. They don't really fit to the rest here. Nonetheless, all right. So now we did a nice simple object, right? There was nothing fancy about it. So now the next big thing that we have to tackle are holes, or any kind of arcs and cylinders, right? So if you look at the right here, then we can see this block, and this block has a hole that has a constant diameter and goes all the way through, right? It's very straightforward type hole. And now the question is, how do we draw that in our drawings? Well, if we start with a front view, at the front view, it's pretty obvious, right? So if we were looking from this direction, right, then we see kind of these four edges, right? That would be our outline, and then of course we see that hole. We kind of see the outline, the diameter of that hole, and that's what we would draw. Now, in order for everybody else to know that this is a hole and this is a circle that we're drawing, we have to add these additional lines to it. And so here I have them in red, but usually they'd be black, just like all the other lines, because of course our pencils aren't very good at changing color. I just put them here in red to point them out, right? So these lines here are what we call center lines, right? So they go through the center of the circle, right? So if we see the full circle, then we'll always have these two center lines. Even if we see an arc of that, right, we still would have the full. We'd have so if this were just a half circle or something, we'd still do a center line for that half circle. And of course, those two lines meet exactly where the center of that circle is. That's why we call them center lines. In general, this type of line, right? So we have it that's basically a dashed line again. But now we have long dashes and short dashes, right? So for the hidden lines, we just had the same length of dashes. But for these center lines, we have long dashes and short dashes. So in this case, the long dashes are on the outside, and the short dashes here are the ones that cross. In general, this type of line represents something where there's a symmetry, right? So they're also called symmetry lines. All right, so this would be if we look at the front view. Now, if we look at the top view, that'd be, of course, our block up here, right? So we see, if we take the camera and just take the picture, right, in our glass box, then all we would see is this black outline, right? But we already talked a little bit about the idea is that we treat these as being semi-transparent, right? So that means if we look down on this and we kind of would be able to kind of look through it, then we would see this cylinder that goes through. And so that's what we have to add these green ones here. These are the hidden lines, right? These are just regular dashes. Dashes are all about the same length and the spacing is about the same, right? So these dashed lines here now represent the edges of the cylinder if I'm looking straight down on it, right? If you think about a cylinder, if you look down, if you look at the cylinder from the side, right, then it looks like a box. And this is what we see. And then we also have to add the center line, right? So to show that it's that this is not we're not representing the hidden lines don't represent something that has straight lines but is a circle, right? Then we have to have our center line that goes through and goes exactly along the center line of the cylinder. And of course, if we look from the right hand side, then we do the same thing, right? So all we'd really see would be the gray box on the side, which is our black outline. But if we're going to look through it, then we see the hidden lines on top and bottom, and then in red the center line. Right? So this is the idea of center lines, and we'll do an example with center lines in just a little bit. Now, before we do our example, there's a little bit of a trick that you can use, and depending on how good you are at sketching circles, right? So if you're like me, then I'm not really good at taking a ruler and doing a straight line, but if I have to do a freehand circle, then that becomes a little tricky. And so here's kind of because we're using this orthographic paper, right? We have nice little boxes everywhere. So one thing that we can do is if we want to draw a circle, right? We already know that there's 4 points that we can easily find, right? If this is the radius of the circle. It's easy for us to find those 4 circles. Those 4 points, right? The red points. It's basically just, if I start at the center, going the radius to the left, to the right, I'm sorry, the radius up, the radius to the left, and the radius down, right? Those are easy. And now we can start drawing that circle easier. But that still gives us pretty odd looking shapes often when we draw these, especially if these are a little bigger. So it's helpful to add another set of points. And to do that, we draw the diagonals into our box like this. And now if you look at the diagonal, you can see that I have, there's my pen, right? So if I look at my diagonal, then I see that I get these triangles everywhere. Right? I get this triangle. And of course, I know if the radius is here, then I also have the radius there. And then I get what we call the D here. That's not the diameter. It's not a good choice of letters. I should find something else. I put D for diagonal, but like now that I see it, my people might think that's the diameter, which of course it isn't, right? But this would be the diagonal of one of these lines. Now, of course, based on Pythagoras' theorem, right, we know that if we want to find the length of D, then all we have to do is over here the formula, right? So it'll be r squared plus r squared into the square root of that. Then if we combine those, right, that gives us r times square root of 2. And then if we want to be approximative about it, then we can say, well, r times the square root of 2 is about r times 1.414. Right? Square root of 2 is 1414, right? That's easy to do. Now, of course, if we want to be very exact, then we can say like, well, we can take this and now multiply our radius by 1.4 and then draw this point. But of course, that's going to be extremely time consuming. We'll never get around doing that, right? So, but what we can actually see is that if we take this length, this D, this diagonal, and if we multiply it by 3/4, then we get something that's approximately 1. So 3/4 times 1.414 is about 1. Not really, but close enough for us, right? For a sketch. Comes out to be 1.06 or something, right? But relatively close. So that means we can approximate where the radius is by just taking 3/4 of this length. And of course, for us, for most of us, it's relatively easy to find where 3/4 or something is, right? We can say, well, I take this line and I cut it in half to be about that, right? That'll be the half of the diagonal. And now I take what I did and I cut it in half again. Right? In my case, comes out a little too far. It wasn't a good sketch, right? So that means my my point is somewhere here. And of course I can do that all the way around. Then I get another points. And now I have 8 points, and that makes it relatively easy to sketch, right? So these arcs that are between these points are relatively short, so it's relatively easy to do. So basically, whenever we want to do a circle, all we have to do is do these four easy corner points, and then we draw the diagonal and say, like, I'll do half and a half of the half, and that's where my radius is approximately. Then we can do the circle, and we get halfway decent circles, depending on my daily form. Sometimes better, sometimes not so much. But if your circles look a little strange in your drawings, don't be too concerned. That's not something I'm going to be grading too harshly, right? I want to obviously need to make an effort to for them to look nice, but if they're not perfect, then that's fine. All right, so let's try another example. Right, so let's look at something that is a little more complex, right? Or actually quite a bit more complex. Right, it has a shape that we haven't seen before, and and it has holes in it and a cylinder sticking on it. Right, so let's see if we can do that. And we'll switch to the other camera again, if I can do that. Where is my right there? And then we start drawing. Now, the first thing whenever you want to do something like this is with the last object, right? We kind of said, well, this is our front view, this is our top, and this is our right hand view. So the first thing we usually do is we look at our object and we need to define what is our front, what is our, once we have the front, obviously then the side views and the top view come into play without any changes, right? But so the first thing is, what do we choose as our front view? And so usually what we do is we find the view that has the most information on it. And we choose that as our front view. So in our case, I would say probably this front piece here probably has the most information, right? Because it has the hole in it, and it has kind of a curved edge to it. All right, so that's probably something where we'll say that's pretty complex. The top one also has the cylinder, but it has straight edges, so it's not quite as
But we can also see that the cylinder is like thicker from the front view.
from the front view. The cylinder is going to show up. It's going to show up as a rectangle,
Ah, okay, okay, okay.
right? If you think about, this is kind of the reason why we made these models for the first one, is that we kind of were able to clearly see where everything is. And now, we kind of need to start thinking. We need to start developing our, I guess you could say, our three-dimensional brain to make sure that we can see it. Let me just pull out my example here so that this time I don't draw too big, or drew this one with let me see if I have another course one. Yeah, I like to do this one. So this is now on the course paper, just because when I drew this as a practice, I put it on the course one, and for this one now I know what my size is approximately, right? Because you can see in this one, the same as for your kind of the practice that you're going to do, is there's nothing there to tell you exactly what the dimensions are. You kind of have to come up with those yourselves. Um, but so in our case, again, we're going to take the front view as kind of the view that we see here, like, and as it is. And in general, especially for these practices, um, you will always kind of get an object like this kind of a view, right? And so then, um, if I give it to you this way, then it's probably a good idea to take this front view as the front, like the front as the front view, right? So in the exams and all that kind of stuff. But if you have a good reason to choose a different one, then by all means, right? I don't want to
Dr. Carl, I think your audio stopped working.
Yeah, I can't hear you as well.
How about, is that become better or we're still?
Yeah, now we can hear you.
Now we can hear me. So there's, seems to be that my little plug here is not, it's not able to, you know what we'll do? We'll unplug my, maybe that helps. So the problem is that the computer that I have here on my office only has two, that only has one USB port. So I have everything hooked up on a USB hub, and it might be too much for that USB hub to handle. But you can hear me now.
Yes.
Okay, good. All right, so let's start with our drawing, and we're going to start with the circle at the bottom, right? This kind of this outline right here. To do this, we have to start with the center. We have to define ourselves a center, and kind of looks like this outside edge and the circle both have the same center, right? So again, I didn't put anything here. I think I have a radius for the outside one. Just count real quick: 1, 2, 3, 4. Right, so it's this were a very edge here. So 1, 2, 3, 4. 1, 2, 3, 4. Right, so we can say this would be right here would be the center of the circle for both the kind of the cutout circle and the outer edge. Right, so now if we want to do the outer edge, then we said 1, 2, 3, 4. So this would be one point. That would be kind of the point where my circle starts. Now I do my trick, right? So with an arc, obviously I can do the same with an arc as I would do with a full circle. So I have my one corner point. My other corner point would be the radius downward. So 1, 2, 3, 4 would be here. And then one would be to the right. So 1, 2, 3, 4. Now I can try and draw that arc based on those three, but those are pretty far apart. So I'll get something that looks not very much like a circle. So I'll use the second step, right? Kind of the 3/4 step. So to do that, I first draw myself the diagonal. And again, now this has to be nice and soft. So if it might be a little thicker for me than it should be, just so you're able to see it. You can see this diagonal line that I just drew? This
Yeah.
line right here?
Yes.
Okay, good. Right, so we know this would be the entire diagonal, right? So we said, well, we need to have half of that. Half of that diagonal is here, and then the remaining part is this, and we want to have half of that again, so that would be here. So that would be another point. And I'll go right ahead and I'll start erasing some of these so I don't get confused once I start drawing my circle. Right, so now we've constructed another point for our arc, and we'll do the same on the other side again. We'll draw our, where is our, there. So this would be our diagonal. Do it nice and light so it's easy to erase. The halfway point is here, which leaves me this part. And of course, the halfway part of this is right here. In this case, it was real easy because it lined up nicely with my boxes. Oftentimes, it's not as obvious, and you kind of have to estimate a little bit more, but that's fine too. And now we can kind of already see nicely how this circle comes about, right? So now all we have to do is kind of draw a nice line into that. And often case, you may have learned that when you did graphing in math, right? It's like our hand kind of often is better at doing curves, kind of to curl it out this way, right? So it's easier to do it this way than if I wanted to do it down here. So I often just turn my piece of paper around, and then we know when we start here, this is kind of almost comes in straight, and then we kind of do our also when it's not coming out perfectly, but something like this, right? As you can see, my circles aren't.
Are we allowed to use a compass?
Yes, the only problem with the compass is that it gets to get the right line thickness is sometimes difficult with a compass. And also for the next step that we'll do, right? So this one is now going from the 3D drawing to a 2D drawing, but next week when we do the opposite, then you can't use a compass for the circles anymore because the circles then become ellipses. So at some point you'll have to practice drawing some kind of an arced line by hand. But if you want to, for these where they are circles, you're welcome to use a compass, of course.
Dr. Bandila, are you drawing the outer circle,
Yes,
like the outer semicircle,
this
or
is
the
now
inner?
if you can see my other my shared screen, right? This is the kind of the line that I'm drawing right now, right? This
Okay,
outer part.
okay, yeah.
And so now the next thing I'm going to do actually is we're going to do the inside circle, right? So for my inside circle, I chose the diameter to be half of that, so 2, right? So again, we start at our center point and we draw the 4 points that are easy to draw. Right? We want to draw these kind of points thinly because they're construction points. I'm going to do them a little thicker because I know, like, that you have to be able to see them, right? So these would be, now I can draw, I can kind of see where this circle needs to be. But again, I can go in and do my construction. Now I'm going to, because these lines are shorter, I'm kind of going to do it a little abbreviated, right? So I know my diagonals are going to be like this. So I mean, I know my point has to be somewhere on that, in that location, right? Again, here, my diagonal, half, 3/4. Was my other diagonal here, 3/4 and 3/4. Right, so this again gives me my circle, and I can start drawing my circle. There we go. Right, halfway decent circle. Again, if your circles don't come up perfectly, that's completely fine. Right, I'm not, can't expect everybody to be a great artist. All right, so now we have kind of our circle here, and we have the beginning of our arc. So now it means we need to have these lines that are going straight up. And I decided those lines to be 2, 4, 6 long, right? So we can draw those in there. 2, 4, 6 on one side, and 2, 4, 6 on the other side. And then, of course, we're going to draw a line across. Right? That's what we would see if we're looking from this side. Right? It looks a little longer here, but again, these are just units that I chose. You're welcome to choose whatever other units you would like to do. All right, so now we have our front view almost done. Right, there's like a couple things missing. The first thing that's missing is, of course, our cylinder. Right, if we're looking at the front view, we can see the cylinder. Right, it becomes something that kind of sticks up out of our page. Right, so all we have to do is we have to draw a basically will look like a rectangle, right? Because we can see, we'd be able to see kind of an edge that goes down here, and the same on the other side, and the height this across would look like a flat line, right, going in this direction. So in this case, I decided this was going to be smaller, so I'm just going to do it 2 boxes across and 2 boxes high, so it looks like a square. Right, this would be our cylinder. We can do it wider, we can do it narrower. That's entirely up to you. And again, there's no, just because there's no units here, right? I'm just at the beginning. We just kind of need to play around with the technique a little bit. All right, so now there's a couple things that are missing, and depending, like, different two people do it differently. Some people like to do it like add all the lines at the end. Some people like to add all the lines at the beginning. I like to use kind of a mix of that. I like to use to add the hidden lines right away, right? And then any kind of other lines like the center lines, I like to add at the end, so it's not so messy at the beginning. But the one hidden line that we'll have is kind of this kind of back edge right here, right, that we can't see, right? Because we know that if this front piece here were be transparent, then we'd be able to see kind of the equivalent to this edge that's going across on the other side, right? So what we have to do, well, we have to do a dashed line across. And we'll talk a little bit more about the rules for the dashed lines, but again, we want to make sure that they start and end with a dash, not with a blank. All right, so this will be our front view. That's basically what we're going to see. And so now we can do the top view, right? So basically looking at the top here.
Dr. Carl, sorry,
Yeah.
what's the dashed line for?
The dashed line is the hidden line, right? So it's if you think about this our gray little like L-shaped piece here, right? If you think about that as being made out of plexiglass or something, right? So you can more or less see through it, then you'd be able to see that there's this kind of other line that goes across. Do you know what line I mean, right? It's kind of if the same in our for our that was here kind of this edge, right? If I think about my this object as looking like, where's the camera, like this, right? If this were now my front view, right? So I'm looking through this object, then I'd be able to see that this line exists.
Okay, okay.
Does it make sense?
Yeah.
Right? The same way that we did when we said we're looking at our object in this way, that we were able to see that this edge exists because we kind of can look through the material to see that edge. Right? So that's what this dashed line is. That's this hidden view. Hidden line, I'm sorry. All right, so now let's do the top view. Right? If we look from the top, then of course all we're going to see is this rectangle with a circle on it. Right? So now we know the width of this rectangle obviously has to be the same width as our part here. Right? So that's we can do. Again, there's no hard and fast rule exactly how far to put these apart. We don't want to put them too far apart. It's kind of up to you. But we can draw this line across. Right? This is, we know this line obviously is the same as this line, so they have to have the same length. And now we can arbitrarily choose the depth. What did I choose? 2, 4, 6, 8. Two, 4, 6, 8, right there. And then the back line is a straight line as well, so we can go straight across. Nice that we have a good rectangle here. And then we can close that. And now we have our circle, right? So we know that our circle has to be somewhere between these two lines, right? Because if I extend these lines upward, it has to be somewhere in here. Where it is, I don't know from this view, right? So I can choose somewhere. So I chose the center to be right here. That's where I chose my center to be, right? So it's not in the middle, it's kind of a little off center. And then we can draw our circle. Now for a circle this small, kind of gets difficult to do our little trick, right? So it'd be half, half, right this. So sometimes with these smaller circles, you kind of just have to wing it a little bit. This one edge looks a little straight.
So that would be the top view, right?
This is the top view, yes. Right, so whenever we do our 3 orthographic views, it's always the same sequence. It's the front view is down here, the bottom left, the above it is the top view, and then to the right side of it is the right view. That's always the combination that we want to have. We always want to have them be aligned in the vertical direction, right? So that the line that's here has to line up with the line there, right? Because they're the same line, and on the same here, and then to the side, we want to do the same thing. Now, before we continue with the right side view, let's get rid of the center because we don't really, there's nothing there, so we shouldn't have a point there. Now, before we get to the right side view, we have to add a couple hidden lines, right? So of course, if we could see this line coming from this direction, we can also see this line coming, looking down from the top, right? So it's the same kind of edge that we see. So let's do another hidden line right there. Like this. And now there's one more set of hidden lines that we have to do. If we imagine that we're looking down on this part right here, right? We're looking straight down along this kind of flange that's going downward, right? Then that means we need to be able to see where the edges of this circle are. Right? If we're looking down along this piece, right? That means we go down to where our circle is, right here. And then we can just put our ruler and say like, well, we have to have a hidden line right here. Right? And the same on the other side. Right? These now represent the edge of the circle. Right? So if we're looking at this without knowing the three-dimensional thing, then we know that there's something going on in this area. All right, so these were the hidden lines. I think that's all the hidden lines that we need to do. And after that, we can now go and do our right side view. And now we can do kind of just as a different example, we'll go ahead and we'll do it without that diagonal construction line, right? Just so that you see both ways. So basically, if we want to do it without the construction line, then we just have to make sure that we start at some corner where we're in the same location, right? So we can, for instance, say that if I'm looking along this line here, right, that we here, right, then I know that starts on this corner, so I can just kind of start going from there, right? So I can say I'll do this as my starting point, right? So now I know that in this direction now I have to go the same length as I went here, right? Because that would be the same edge, right? And here I said I think that was 6, right? 2, 4, 6, 8 now. Okay, 8. 2, 4, 6, 8 right there. There'd be one line, and then of course I have the line that goes, oops, not my pencil, you can't see the mouse, like I see the line that goes all the way down. Okay, so that means from my drawing here, I know this line that's going down has to go all the way down to this location, right? So I can just do my ruler across and say I need to stop here. So this is now my straight line. Now, one thing that's very important to remember, right? So if I'm looking from the side view, right? If I'm looking in this direction onto my piece, then I don't see that this is curved, right? There's nothing there that tells me that it's curved. The same way that when we looked at our other object here, right? That we can't really see if we're just looking straight that if this part right here, if this goes straight up, right? If this was just a straight line, if this is angled in, if this gets angled out, it doesn't matter. All we can see is that it starts here and it ends there. So that's why we do a straight line all the way down. And then we said the width of this is just one box. So let's do one box. And the width of the box is the same up here. So like this. And then we can draw this in. Right there. And right there. Well, maybe one more thing to mention as I have my model out here, right? So if you remember when we drew this part right here, right? We said, well, we have to draw this line because there's a change in kind of the angle, right? So we can, if we look at it, then we'd be able to see this line. Now with circles, it's different. So in this case, here, just because that's how the software spits it out, this line is in there. But we will not put that line in there. There's nothing for us to see because the start of a circle is like a gradual thing, right? So there's no edge that we can see. Any edge that we draw on our drawing needs to be in the actual object as well, right? So that's why we don't say there's something here, right, which we where our curving starts. There's nothing to show from this side, so we don't move that. Okay, so before we start adding all the center lines, we of course we can't forget our little knob here, right? So we said the knob starts 2 in, so it'd be here, and we said it's too high, so our little cylinder would be sitting right up there. Okay, so now we have all the visible lines done for our right side view. That means now we have to look at any hidden views. And of course, if we're looking from this direction, again, we're able to see this circle, right? We see kind of the top and the bottom of this circle. So we have to go in. Yeah?
Dr. Bandila, does it matter where you draw that in the square you just drew that represents the cylinder?
Yes.
Like, why did you draw it like 2 boxes from the end?
So if you look at in my top view, right? If you look where my pencil is right here, right? We said that this was our center point and we started. So if we look, the circle starts 2 boxes down from this edge, right? And this edge
yeah,
is of course exactly here, right? So this is why sometimes at the beginning it helps to do these diagonal lines, right? Because you kind of see that this would kind of connect like that. But that's why we have that line right there, because it's 2 two boxes in. And then, of course,
Okay,
the
okay.
diameter is 2, so that we have to have 2 wide. All right. Okay, so now let's not forget the hidden lines for the circle, though. Right, so all we have to do is find where the top of the circle is. Our top of the circle is here. And so we can just go across and do our hidden lines. Sometimes with these thinner ones, as I said, these hidden lines can be a little tricky because there's not that much place to do dashes. Right, so these would be our hidden lines. Now, we have everything here. We have all our hidden lines and we have all of our visible lines. So that's left is to draw our center lines, right? Because we have circles. So now what do we do? Where do we start? Well, let's start with our big one right here, right? So we have this big circle. So usually we want to have our center lines go all the way to the edge of the circle that they're for, right? So in our case, the center here is a center for two circles, right? It's a center for the small circle and the center for this half circle right here, right? So we have to extend it all the way out there. So what we'll do is we'll do a smaller dash in the middle. See, that's halfway straight. Right? So we have a smaller dash, and then we do a longer dash all the way out across where this is. All the way out like that. And then we have to do it in the other direction as well, right? Because it's a circle, and we'll learn about that this is the circular view versus the rectangular view when we do dimensions. Right, again, we want to have one here, and then the longer dash goes all the way across the object, right? So this one is a little bit shorter than the other ones because there's no other half circle there. Okay, so this would be now the center line for the bottom circle. Now, this is a cylinder, right? It looks like a box to us or a rectangle, but it's actually a cylinder. So we have to make sure that people know that. So we'll add a center line here too. So we'll do a shorter dash in the middle and then a longer dash along here. So these ones are a little, let's extend these a little more. So it's probably should have made this one a little shorter to make it clear. Now, what else? Another circle. So another set of center lines. Make this small enough. Go across the edge of the circle. Other direction as well. There we go. And then, of course, here we have another cylinder. So we want to do the center line to make sure that people know that this is a cylinder and not some kind of a rectangle. Now, there's two more center lines that we have to do. And those are the center lines for our hidden lines, right? Remember that these two hidden lines here were the edge of the circle. We have this circle here with a hole, so we have to tell people that this is not a rectangular hole somewhere, but this is a circle, right? So we have to do a center line to that cylinder as well, right? It's the same type of cylinder here. These four lines make a cylinder just like these four lines make a cylinder. Doesn't matter if they're hidden lines or not, they're still a cylinder. Now for these ones, it's going to be tricky because they're kind of the center dash is going to be very short. Like that, and then the same here, right? Because again, this hole is a circle. So we'll do a small one right there, there, and there. So that's what we get. And
So we
yeah,
don't have a difference for example from the front and top view. It's the same lines for the circle and the cylinder.
so for the circle, if we see a full circle like here or any kind of arc, right, then we have to have the two center lines, right, that cross each other.
Uh-huh.
Whereas when we see just the rectangle of the cylinder, just the side view of the cylinder, then we only take the one line, right? We don't, there's not a second one that goes across here.
Okay.
That's because again, these center lines kind of represent the what's gonna call it, the
Right.
symmetry, right?
Okay.
So if I look at a circle, I could draw any number of lines here that all create symmetry, right? Because it's a circle. Whereas in my rectangle here, in my cylinder, there's only one line that creates symmetry.
Okay.
All right.
Yeah.
And I think that's all. Let me look at my notes to my testing here. I think that's all the lines that we can get. All right. So now want to be real careful. We probably there's a couple little lines that we just drew in here. Probably want to close out some of these uh, construction lines from our circle. We'd usually probably also, oops, we should also probably want to get rid of like these little construction dots that we did. We want to make those like easy to remove as well. Because again, like the idea is that we want to get drawings that are really nice and clean. And for the in-class work and homework, I want to make sure that you make nice, clean figures. I'm not sure if we're going to get to in-class work, so maybe we'll move some of that in-class work to next class. Maybe we'll see. All right. Are there questions about this drawing?
No.
Again, I will post this video, and you can always go back and kind of, if you need to do it at a different pace. We just lost somebody.
Zacarias.
Yeah. I hope he'll be back. Given up on us. So now let me get back to the other camera. See if that works this time without turning everything off. Very good. So now you can still hear me, I hope.
Yes.
Okay, good. Then, so this was how we treat circles. So now let's talk a little bit more about technique. So we've talked until now about 3 different line types, right? We talked about the visible lines, and when we draw those should be the thickest lines, right? Those were the ones that show us the outline of our entire system. Those should be the clearest ones. And then the hidden lines are dashed, of course, and they're not as thick. They're a little thinner than the visible lines, and then the center lines should be thinner than the hidden line. Now, I completely realize that for us, um, I count myself almost to it, beginners of these drawings, right? It's really difficult to make lines that have really distinct thicknesses with just a regular pencil without that getting different mechanical pencils and different strengths of stuff. Um, so I would like you to make an effort to make it clear what the visible lines are like a little stronger. You can push down a little harder, whereas with the other ones you're a little thinner. But again, that's not something where I'm not gonna ding you for on a homework or anything like that. But you should know that the visible ones are the thickest, and then the hidden lines and the center lines kind of get thinner and less prominent as we go along. All right, some rules for our hidden lines. Visible lines, we don't really need any rules. Wherever there's a visible edge, we have to put a line, right? So there's not much there. So rules for hidden lines. The length of dash depends on the length of the line, right? So we already had the problem where we have really short hidden lines. It's really, we have to make pretty small dashes. If we have real big ones, then we can have the dashes be longer. But we don't want to do a whole bunch of really small ones. Usually the empty spots aren't quite as long as the filled spots in these dashes. Another one is that the hidden lines should end in a dash, not in a blank, right? So if we look at the example down here, for instance, right, this black line here, the vertical line would be a visible line, and then we have the hidden line come here, and it connects, right? This dash here connects. This down here would be the wrong way, where we kind of end a dash, and then we don't really know if this connects or it doesn't connect, right? So that's why we wouldn't want to do that. We always want to have the hidden line go all the way to where the visible line starts. What else do we have? Now, if we have 2 hidden lines come together, right, that'd be the second box, right? Then we always want to have that wherever the two intersect, we want to have dash hits dash, right? That would be this one here, like the black part hits the black part. We don't want to have black on one side and empty on the other, or the other way around, right? So this is not what we want to do. Again, if you do this by hand, sometimes that gets a little tricky, right? You might have to erase your dashes and redraw them, because like you did a dashed line for a hidden line, then you notice that you doing the second one that intersects, and like you run into basically into this problem right here, where you drew this line first, and then you're drawing this extra line, and it hits an empty spot, right? But you'll figure that out. We also want to have dash hit dash when we have any kind of a change in direction, right? Any kind of corner. So at these corners, we want to have them come together even if it's an angled corner, we want to have these come together, right? So that's basically we want to do that because we want to know exactly where this corner is, right? If we kind of end this dash here and this dash there, then we don't really know where this corner is. Now, of course, with any rule, there's exceptions, and the exception is that if you have a visible line like this that is parallel to a hidden line that then comes out, then you should not have the hidden line directly connect, right? Because then, especially if you're like me and your hidden lines and your visible lines have a similar thickness, right? Then it's kind of difficult to distinguish where the hidden line starts and the visible line ends, right? So that's why I would want to leave that open. The same if they're coming from both sides. All right, so these would be some rules about hidden lines, and you'll do a couple of those, and you'll figure them out. Now, center lines, right? That's the other line that we did. We basically have three different reasons for using these center lines. The first one is the lines of symmetry, as we just used for circles, right? So if we have a circle, we do the two lines. If we see that the side view of a cylinder or of a hole, then we just do the one, right? Because if we do a one that was vertical here, then that doesn't really show a symmetry. The other thing that we can use them for is if we have a part that has a circle of features, right? So we have this disk here, what from this outer black line, and this disk has four holes in it, and these holes are all sitting on a circle, right? Kind of a diameter. They're all the same distance from the center, right? So we could do another center line that goes through all these, right? You can see we have the short dashes where they intersect, and then longer dashes, and short dash, longer dash, short dash, longer dash, right? Of course, because it's overall a circle, we still have to have the center line that goes through the entire thing. And so you can see basically we have at the center of these smaller, kind of have two center lines come together, right? There's the center line for the big circle and then the center line for the smaller circle. That makes it a little tricky. And the last thing that we probably won't use at all, I mean, probably even this circle of features we're not going to do by hand, maybe once we do Inventor. But one thing that it's also used for, but we're not going to really practice, is if there's a path of motion, right? So if we think this is some kind of a pen or something, right, that in our object can move up and down, right? Then we'll draw it in one location, and then we'll indicate that it can move by this kind of a center line. But again, that's probably not something that we're going to practice. Now, some rules here as well, right? So we always want to start and end with long dashes, right? So if we look at our circle here, like the long dash is always at the end, up here and down here as well. This is the other example. And whenever these lines intersect, right? So if you have a circle, then we want to have them intersect either both at the long one, like here, right? So we have long dash, short dash, long dash, short dash, long dash, and long dash, short, long, right? So they're intersecting where both are long, or we want to have them intersect where both are short, right? Here would be long, short, long, long, short, long, right? So that's what we want to do. And not sure why that circle comes in. The red circles were the ones that were supposed to come in and out. But we have our red circles right here, right? Those would be here that would be wrong because the last dash is a short one, right? To be short, long, short, long, short. We want to end in long dashes, not in short dashes. And of course, here this would be wrong because we're intersecting a long dash and a short dash, right? So these are the rules for these center lines. There's a couple more rules for center lines. Um, these center lines shouldn't end where our visible lines are, right? So we always want to draw the visible lines just outside of the feature, right? So if this feature here is the circle, then our center lines should go just beyond the circle. And what just beyond means really depends, right? Sometimes it's longer, sometimes it's shorter. Uh, Sometimes, like we have right here, right? We could have them end before they go on to the next feature, but like sometimes it's just looks nicer if it goes all the way across. And here we have a couple things that are not right, right? So like this center line from here, for instance, that ends too early, right? It shouldn't end at a visible line. uh, dash on the red point, and the same up here, right? So this is good because it goes beyond the circle that is the main feature, but it still ends at a visible line. And the reason why we don't want to have these long dashes end on the visible line is the same problem as before, is because we might mistake them then as visible lines, like especially if we're doing it by hand and the thickness is not so different. Right here, we could probably see that the thickness is sufficiently different that um, we could figure it out. Now, another thing that we can do with these center lines is we can indicate that a whole set of circles are all kind of sitting on the same at the same line, right? So there's all are connected, right? So if I wanted to say that the distance from the center of these circles to the bottom here is a certain distance, right? Then I would only have to say that once because they're all sitting on the same line. Now, just briefly, there's some less common lines as well that you should know about. The phantom line is similar to kind of a mix of hidden lines and center lines, right? So they have a long dash and then two short dashes instead of the one short dash for the center lines. We use phantom lines for repeated details, right? So if there's something happens over and over and over and over in our drawing, then we just do it once or twice and then kind of show with phantom lines if there's more of them. Um, if I'm drawing a part that I want to manufacture and I have another part that's connected to it, but that's not really part of the manufacturing process, and sometimes we'll draw that other part as phantom lines so that we kind of know where it's supposed to go. Um, and then, as I said before, right, we have these. If we have movable parts, then sometimes we'll draw kind of the other extent of it as a with phantom lines. Another thing that we'll use is break lines, right? So if we have something, if I'm doing a drawing of something like this pencil, right, then I can see that between somewhere here and here, there's really not much happening, right? So there's really no reason for me to draw all this. So what I could do is I can just draw the tip and draw the end and then do these squiggly lines in it um, to show that there's a break and then give a dimension that says how long it actually is supposed to be. And if it's a relatively short distance, then we do the squiggly line. And if it's a longer distance, then we do this pulse kind of thing, right? That's what we do. And then the last one is what we call a cut plane. So that we do that if we want to show the inside of an object, right? So we'll draw a line, say here's a cut, and then we'll do drawings of cuts, and we'll talk about those a little more when we get to Inventor and actually have Inventor do those cuts for us. I think this is probably now getting to the end here. So we talked about the different lines that we had, right? So we said the main ones that we're going to use are the visible lines, the hidden lines, and the center lines. But we also have the other three, right? We have the phantom line, the break line, and the cut plane line. And so basically when we're drawing these and two of these lines are on top of each other, then we only draw the more important line, right? The line that has precedence. And the ranking that we use is basically we start with the cutting plane line and then visible lines, hidden lines, and center lines. Right? So that's kind of, so if I have somewhere a hidden line and there's a center line that's in the same location, right, then I don't kind of try and draw them right next to each other or something, then I just draw the hidden line and the center line gets blocked out. All right, I think it's one last thing, or is it? Yes, one last thing. Very good. So now, if you remember back to Monday, we talked very briefly in the title block that we have something that talks about projection. And so there's two different types of projections that we can get. We can get the third angle projection, which is basically what we have, right? That's what we talked about, right? We look at from the front, we look from the right side and from the top, and that's what gives us these the three locations, right? Our front, our right side, and our top. But now we can also do it slightly differently, and that is we can say what's called the first angle projection. And that's the symbol for first angle projection is kind of here. And the idea here is that instead of having my glass, like have the glass box, I'm surprised, thought I'd gotten rid of some lines here as well. Oh well. So basically what we have, instead of looking on the outside of the glass, we're now looking at the inside of the glass. And we're using this back glass pane right here as our main one, right? So we're taking whatever we can see and we're projecting it back onto that screen right there, right? So we get um, the same drawings, right? So we get the front view, we get the right side view, and we get the top view, but now they're in different locations, right? If we go back to the other one, it's the exact same three, but they're just in a different assembly, right? And you can see if you look at the top here, there's the two different symbols I think that exemplify which one is third angle and which one is first angle. So we will mainly focus, or we will focus on the third angle projection. We're not going to do any first angle. So we won't have to specify it. But I thought at least you should know of the existence of a first angle. All right, let's see what time it is. Oh, we're almost out of time. All right, so I have three 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 practices for you to do, all on orthographic paper. So it's Ortho 1, Ortho 2, and Ortho 3. And so considering we don't have a whole lot of time left in class, or no time left in class, let's say, how about let's do 1 and 2. And then we'll do 3 either together on Monday, or we'll just do this one together on Monday. And these, I think I ran out of time to post these, but I'll post these. Did I post these already?
Dr. Carl,
Yeah.
how are we supposed to know, for example, the height of the object?
That's up to you. Just like I did for the other one, I just decided on one. Right?
Okay.
Just choose one that fits onto your piece of paper, basically. I'm not gonna
But I mean, I don't know. For example, let's say that I want to say that the square on the bottom is 4 centimeters every side.
Okay.
How do we know if the height of the other part is either 4 or 2?
It's up to you.
Okay.
It's really up to you, right? Like if you remember, if you look at this drawing like that we did here, right?
Yeah.
It doesn't really look like the part that we did, right? It looks certainly the top one is too thin and all those kind of things, right? So it's really more for you to practice doing these drawings, right? I'm not really concerned about it being any kind of specific size. So what I'm really looking for is that you use the right line types. You have a hole here, right? So you want to make sure that you do center lines, right? You have a curve here, you have two curves here, different ones, right? So you'll have to have different you have to put center lines for those as well. If you think there's not a whole lot of you have to have hidden lines for where this hole is, right? If you look from the right side. So those are the things, and I want you to do them nice and clean, right? I want to have real nice, like construction lines should be great.
Your example, what you just did.
Yeah.
Upload that. Okay.
Exactly what I just did. Like exactly what we did for this one right here, right? You just have to kind of
upload it to Blackboard.
Well, the whole video of today goes up on Blackboard, right? And I can put this the drawing up there too, the finished drawing, if that helps. I can check. Probably won't be able to do that until the weekend, though. I have a couple older ones, videos where I've done drawings, so I can post those as well, if that helps.
Okay, thanks.
Are there any questions?
So which ones do we have to draw?
Let's do 1 and 2. These two, and I'll post those as assignments on Blackboard just to make very clear what it is, and they'll be due on Monday. And of course, if you have questions about them, like if you start a drawing and it doesn't work somewhere and you get stuck somewhere, then just let me know. Right? This is kind of a a craft to learn, right? And so with a lot of crafts to learn, it's like you have to practice a little bit and get hints as you go along.
Okay.
So I know that both Paula and Zacharias had me in several classes now, so they know that they should ask questions whenever they have questions. Uh, Benjamin, I know I only had you in one class until now, right? And so you may not be as comfortable or as used to asking questions. So, but just make sure whenever you have questions, ask me. If you're doing these drawings as your homework and you're getting stuck, you're not understanding, doesn't look right, there's something odd with it, you just take a picture, send me an email saying, hey, Dr. Carl, is this, am I going in the right direction, right? That's, it's very important that you ask questions because you learn by asking questions, and I learn by you asking questions because I'll stumble over stuff.
Okay, okay.
Yeah, just feel free to ask. All right. Then I think if there aren't any more questions, I'll go ahead and stop the share and stop the